All right, good afternoon, everyone. We are going to work on the test review worksheet number 2. So just a few announcements here. We will have, I'll have a help session soon after school ends today. It'll be a help session. I'll record it, but I may just also put it on my website as well as a link under today's date. Tomorrow morning, I will have a help session, morning test review session. I'm working on a test review worksheet, so I'll put that up later this afternoon or evening. It's a little bit earlier because I have a meeting at 7:45, so it's gonna be early in the morning from 7 to 7:40. But if it's too early for you and you still want to watch it, you can watch it after I record it, and I'll put it on my website. All right, all students will be taking this test virtually tomorrow over Teams, through Teams. So yeah, no face-to-face tomorrow, and our test will be 7 questions. So pretty much the length of this here: 1, 2, 3, 4, 5, 6, 7. So you have kind of 7 sub problems, and that's what you would expect. That's what's to expect on the test. Okay. Any questions before we begin our worksheet? All right, so let's begin. Number 1. We have f and g are functions given by f of x, which is 1/4 plus sine pi x. That's this curve here. It looks like a parabola that's opening downwards. And then we also have 4 to the negative x. That's this curve here. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graph of f and g. And S is the shaded region in the first quadrant enclosed by the graph of f and g. Okay, so part A, find the area of S. All right, so we can tell that here in region S, our functions are given to us as y equals, everything's in terms of x. So this is perfectly set up for top minus bottom. So I think we can just rely on top minus bottom to get to the area. Now, if you look, all these rectangles here, no matter where I draw the rectangle on, as long as it's within this orientation here, the top of every rectangle is hitting the same curve. So there's consistency there. And the bottom of every rectangle is hitting the same curve. So there's consistency there as well. So we only need one integral to produce area. So we're choosing between these two here, top minus bottom or right minus left, but looks like everything is set up nicely for top minus bottom. So we have the graphs necessary to put into this region or put into the formula, but we are still in need of the bounds. So the bounds we can tell are the intersections between these two graphs. So we'll rely on the calculator to get to that. All right, so I'll do the graphing calculator first and then show on the 36 Pro. All right, so go to y equals, type in your function here. So 1/4 can be represented as 0.25, so I just put 0.25 there, plus sine pi x. Make sure that you're in radian mode, always. And then I'll let y2 be 4 to the negative x. I'll do zoom 6 to get a picture of the graph. And then we'll see if we need to zoom in any further. All right. So right in this region here is where we're interested in looking. So we'd like to zoom in a bit more. So do zoom 1. We'll create a box in that region there. Hit enter. Oops. It doesn't matter which order All right. All right, so there are my two intersections here. I'll look for this left intersection first. So second trace, go to 5, second trace, intersect, hit enter. So I'll choose a point near the intersection on one curve, hit enter. And I'll choose a point close to the intersection on the second curve, hit enter. And now it's going to look for that intersection for us, hit enter again. Intersection 0.178. Okay. I only need the X value because we are just doing top minus bottom. We have the X value already, but the Y value, I'll just go ahead and put that down just in case we need it later on. Doesn't hurt just to have it in case. All right, so I have my X and Y value for my intersection. Now I need to find the other X value here. So second trace again, intersect. Same graph. I just want to pick a point closer to my second intersection. Hit enter. Okay, relatively close to the intersection, hit enter again, and now it's going to find that intersection for us. So it looks like it's landing right at 1, and then the Y value is 0.25. All right, now I think we have everything we need. We have our, we're just going to match with our area formula here. Top graph minus bottom graph. Depth integral. We are targeting the X values, which we've gathered. So 0.178 and 1. Okay, top minus bottom. Top is sitting on that 1/4 plus sine pi x. Minus parentheses. Top minus bottom. The bottom of my rectangle is sitting on the 4 to the negative x. All right. Practice entering it into your calculator. And no pi involved here. There's no rotation, right? We only do rotation if it's volume, and if then we have to decide between disk and washer. But here it's just area. No, not a three-dimensional calculation here. So just 0.410 and area, two-dimensional, 2 dimensions here, so unit squared. All right, any questions there? All right, part B, find the area of R. Now we're looking at this region here. So it looks like we can also do top minus bottom. I think the bounds are already identified for us. But what do you notice is different about this top minus bottom? Anything stand out to you here?
It's along the y-axis.
Yeah, okay, that's true. Yeah, so the bounds are different, right? We can say from 0 to 0.178, but can we just do the same thing that we did for area S?
No, it's the opposite.
Yeah. Good. Yeah. So I want to just make sure that we understand, right? Anytime that the graphs intersect each other, a lot of times your top and bottom function end up flip-flopping. So yeah, so our top function here is going to be the 4 to the negative x, and the bottom one is going to be that 1/4 plus sine pi x. Okay, just want to make sure we are able to see that. top one here. Here. Okay, so we're starting at 0 and we're ending at 0.178. Top of the rectangle is sitting on the 4 to the negative x minus, all right, so now we definitely need a set of parentheses here. 1/4 plus sine pi x. All right. Make sure we practice entering this in our calculator and see if your answer matches mine. 0.0648 units squared. All right, any questions with area? All right, moving on to part C, find the volume of the solid generated. So now we're not talking about volume. We see the word revolving, we know there's rotation going on, and our axis of revolution is y equals -1. All right, so now because of rotation, we know there's going to be circles involved. So this is going to be disk or washer method, right? So we got to make a decision here between our two methods that involve rotation, but we first want to see where that axis is in relation to our shaded region. So y equals -1, that's going to be down here. Okay, so now from our, okay, yeah, so now we have to decide, right? Is this going to be this method or washer method?
Washer.
Yeah, washer method. We see this huge gap between the axis and the shaded region. So this is going to be washer method, means that we have to rely on a second radius to subtract all this space out so that we don't include it in our volume calculation. Just as a reminder, we can always tell from looking at this stage of the problem whether it's disk or washer method. So just some other examples here. Remember, disk method is only applicable if the axis is up against the flat surface of the shaded region, so we can't see any space at all. That's an indication that's disk method, okay, that there's a need for only one radius. But this is where I think I see students mixing up the different methods. I think some students see this as well as touching. It's touching the curve, so shouldn't it be this method? It is touching, but there's still all this gap that needs to be accounted for. We have to subtract all this out. So this is going to be a washer method. Okay, so the only time with this method is where it's not a single space between, there's no gaps at all. But if it's a curved region up against the shader, up against the dotted line, or if it's complete space, then we have to understand those are washer methods.
Mr. Yang?
Yeah.
For this problem, would it have been disk method if it was revolving around x equals 0?
Yes, it would. That's right. Yep. There is a flat surface here. If there's x equals 0, this would be this method for region R. Yeah, for region R. Yeah. All right, so we know we have to draw two radius. You guys said washer method. All right, so from axis of revolution, this is the true center of the object here. This is going to get rotated over to this side. So I want to keep reminding us that this is the center of the object, which means that when we draw our radius, both our radius are going to extend from this point up, and big radius will extend to the further boundary and little radius will extend to the closer boundary. Okay, so big radius first. call that big R. Followed by little radius. All right, let's see. Everything is ready for us to use. This is top minus bottom. No need to adjust any of our equations. So we have this one here is y equals 4 to the negative x. So anytime that we are applying washer method, we're looking for 3 equations to use. And so here we have our 3 equations that will be used to help create our radius expressions. Okay. Big radius first. Top minus bottom. The top is sitting on the 1/4 plus sine pi x. Minus big parentheses. Bottom of big radius is sitting on the -1. 2 negatives become positive. You can leave it like this, or I'm just going to go ahead and combine some like terms. 1/4 plus 1 is 5/4, just so there's less numbers to enter into the calculator. All right, moving on to little radius. Okay, also vertical, top minus bottom. Top of little radius is sitting on the 4 to the negative x. Minus parentheses. Bottom of little small radius is at the -1. Combine like terms. Well, no, sorry, no combination of like terms, but we can resolve the 2 negatives here. Okay, so top minus bottom for washer method. Here's my formula that I'm going to be using. Right, we have the bounds that we can bring down from part A, right? We have those bounds, we can insert them. We have big radius, little radius. Make sure that you're taking the time to square them independently. We can't subtract it and just put the square out once, okay? We got to square these terms, these expressions separately. Right, so we're going from 0.178 to 1. All right, big radius, quantity squared. Minus little radius squared dx. Put into your calculator, and our volume is going to be 1.451 pi units cubed. All right, any questions so far? Okay, same shader region for part D, but now we're talking about cross section. Now we're no rotation going on. We're just building different shapes on top of this this shaded region. The first, once we identify our shaded region, in this case is region R, it's going to be this region here. The next next order of business is identifying what orientation is our base length, right? Is our base length going to be vertical, or is it going to be horizontal? Okay, and so we want to pay attention to what is described, because we're given explicit ways to identify that. So y-axis, parallel to the y-axis. So y-axis is here, vertical. We want parallel to it, so same orientation, also vertical. All right, so. Just like how we did with region R here, 4 to negative x is on the top. And the bottom is the sign. Okay, so here's my base length. Top minus bottom. Top is sitting on the 4 to the negative x. And the bottom of the radius is sitting, sorry, bottom of the base length is sitting at the 1/4. Make sure you put big parentheses. We have to make sure we keep track of the fact that there are multiple terms that needs to see that negative. All right, there's no like terms here, but I can distribute the negative through. That just means less parentheses to keep track of. So that's just 4 to the negative x minus 1/4 minus sine of pi x. All right, next up, what shape are we putting on top of this shaded region? And description says isosceles right triangle with leg on the base. All right, so let's look here. Isosceles right triangle with leg on the base. That's just right here, right? 1/2 base squared. All right, well, we have our specific base expression, right? So we'll take our base length and insert it into this space here. All right, so area 1/2 Okay, so now we can put it into our volume formula. So if we look our cross section, we're doing top minus bottom here. So we just have to take that area expression and insert it into this space here. All right, our region, we've already found the bounds, right, from part B. So from 0 to 0.178. And then we built our area expression, so that can now be inserted here. All right, practice entering into your calculator, and we should get 0.016 units cubed. All right, any questions there? Okay, back page. Given the region below, we have natural log of 4 minus x, that's here. Line x equals -1, that's here, and then the x-axis. All right, so I'm going to fill in our shaded region here. Volume. Okay, so we're back to volume here. revolving rotation here around x equals -1. All right, so we know that once we draw this axis, we should be able to tell whether we're dealing with a disk or a washer method. So x equals -1. Here's -1. All right, what can we conclude here? Disk or washer method?
Disk.
Yeah, this method's right up against that flat surface, right? We don't see an inch of space between, and that means there's no need for a second radius, no need to subtract any gaps or holes after the rotation occurs. All we need is one radius. All right, so the way we draw a radius, this is the true center of the object because we know that this is going to rotate over to this side as well. And our radius always will extend perpendicular to our axis of revolution, so our radius will extend to the right. So if we are doing a right minus left, if we're doing a horizontal, oh yeah, sorry, we said this method here. Put that here. All right, if you see a horizontal rectangle or horizontal radius or horizontal base, you know that there's some additional work on the front end, right? We have to get our equation in the correct form. We know that this is the indication that our equations are most likely not ready for us to use. And that's exactly the case here. Here, this is y equals natural log of 4 minus x. This is in the form of y equals. That's perfect for top minus bottom, but not quite ready for right minus left. So we have to do some adjustments with our equations. Okay. So let's work with that. Y is equal to natural log of 4 minus x. All right, so what I want to solve for x. I want to get x by itself. What can I do first to help move us towards that?
E to the y on both sides.
Yeah, so we can't divide natural log to both sides, right? This is not an independent term. These are stuck together. But what we can do is we can involve the inverse of natural log, and that is a way to kind of undo this expression and allow us to get to that x. So okay, raise both sides with e as the base. And that will cleanly take out what we want to move. Okay, parentheses can drop. I'm left with e to the y is equal to 4 minus x. Now that x is free to move around, I want to get that x by itself. This is a negative x, so I'm just going to add x to the left side and subtract e to the y to the right. All right. Now we have something that is in perfect form for us to use for right minus left, right? We want our equation to be in the form of x equals. So this one's ready to go. All right, this method, we only need two equations to build our radius. So, and we have the two equations. They're both in the correct form. They're both x equals. All right, so we'll do right minus left. Okay. Right endpoint is sitting on the 4 minus e to the y. Minus parentheses.
Mr. Yang,
Yes.
do we use a calculator to find the bounds for this?
Yes. Yeah, I'll talk about that in a moment.
All right.
But yeah, you may need a little help from the calculator. Left endpoint is sitting at the -1. Here we can combine like terms. This becomes a positive 1. 4 plus 1 is 5. So 5 minus e to the y. All right, we said this method for horizontal. So I'm going to write this one. All right, the formula that we're going to be using, and then we can see what else we need. Okay, our radius is good to go, but let's think about the bounds, right? We have to change the way that we think about bounds. It's no longer, we're not stacking these disks from left to right. We're stacking them horizontally from the lowest to the highest y value. So the lowest y value, that's easy to spot, right? That's just going to be that x-axis, which is y equals 0. But the highest y value is going to be related to this intersection, right? And we know that this intersection is basically just along this graph of natural log of 4 minus x. Now, we know what x value this is. We just don't know what the y value is. So just think of it in terms of, okay, I'm just trying to find my ordered pair here. I know my x value must be -1 because it's, right? I'm just looking for my y value, which I don't know yet. Now we can rely on this 4 minus e to the y, but I think it's easier to just go back to the original equation, right? It's easier to work and think in terms of something that's y equals, especially if we're plugging stuff in. So we know that this graph, this curve, is y is equal to natural log of 4 minus x. Well, I know the x value, so I can just find the y value by taking that -1 and putting it in here, and then whatever that y value is, that must be the y value that I'm targeting here. So I'll put -1 into x here, and I get natural log of 4 minus -1. 4 minus -1, that's 4 plus 1, which is 5. Natural log of 5 is the y value. Now, this is completely fine, but if you want to get a decimal value out of it, you can also put in the calculator and say natural log of 5 is 1.609. So we found the y value of that order pair, which also happens to be what we need for our bound. Okay, this is the highest point of my y value of the shaded region, and lowest is 0. Okay, so now we're ready to insert. Everything that we need is identified for our volume formula. Big radius squared. Enter into your calculator, and you'll get 12.236 pi, and then units cubed. All right, any questions there?
In the calculator, we changed it to e to the x, right?
That's right. Yeah. Don't do anything in the calculator except variable x. Yeah. If you try to change it to y, it'll complain. You won't get the answer that we're getting here. All right. Part B. Still volume, still rotation. Different axis of revolution here. So that's going to be all the way over here. Okay, disk or washer method?
Washer.
Yeah, this is washer, right? All this gap here. Even if the axis was all the way over here, touching the graph, that's still not enough for disk, right? It's got to be up against a flat surface. The only way that we can have disk with this shaded region is if our axis of revolution was here or here, right? Everywhere else, we got to do washer method. Our axis is vertical, so we know that our radius must be perpendicular to it. So therefore, both our radius will be horizontal. We're going to extend from our axis. This is, again, the true center of your object. This is going to end up rotating over to this side. So we're starting at the center, and we're building our radius out. Okay, big radius first. Extend from my center to the outermost boundary of my shaded region. That's my big R of y. Okay, little radius, it's going to extend from same starting point, but it's going to extend to the closer of the two boundaries. And that's lowercase r of y. Well, we see right minus left, we see horizontal radius, we know that additional work is ahead of us, but the good thing is we've already found all that information from part A, right? So all that we can just bring down, right? We have everything that we need. We've already gathered all that from part A. So let me just identify here. This curve is x equals 4 minus e to the y. This line there, that's x equals -1. And we have AOR x equals 4. So every equation that we need is in the right form. We need 3 equations to help build our radius, or 2 radius, and we have everything we need. Okay, washer method, right minus left. Let's find our big radius first. All right, right minus left, right endpoint is sitting at the 4. Minus big parentheses. Minus the left endpoint is sitting at the -1. 4 minus -1, that's just 5. Little radius. Right minus left, right endpoint is sitting at the 4. Minus big parentheses. And the left endpoint of my little radius is sitting on the curve, which is the 4 minus e to the y. If I distribute the negative through, I can combine some like terms here. 4 minus 4 is 0. The negative distributes, so the 2 negatives become positive, so the 4 goes away. I'm just left with positive e to the y. Okay, so we're targeting washer method, right minus left. So we're just going to fill in what we need for this formula. Okay. Same orientation, same shaded region, so our balance is going to be the same from part A, right? Lowest y value to highest y value from 0 to 1.609. All right, lowest y value 0, highest y value. Okay. Make sure that we're squaring both our radius separately. 5 squared minus e to the y squared. Enter into your calculator. Okay, units cubed. All right, any questions there? All right, one last one here. We're back to cross-section problem. So we're building a shape on top of this flat surface. No rotation here, but next, our next step is deciding whether to draw our base length horizontal or do we want to draw it vertical. Okay, so we look at our description here, parallel to the x-axis. Okay, so x-axis, that's this direction, horizontal, parallel to it, so we're going to keep it horizontal. Well, the nice thing is these are all right minus left, so everything we've already gathered from before we can bring down. The bounds, the equations, so we're able to reuse a lot of information here. Okay, our base, right minus left. Right endpoint is sitting at the 4 minus e to the y. Minus parentheses. Left endpoint is sitting at the -1. Two negatives become positive. 4 plus 1 is 5. All right, we have our base length. Next up, what shape are we building on top of this surface? And we're building a rectangle whose height is 4. All right, so we go to our rectangle formula. Area equals base times height. Five minus e to the y. That's my base, so I can just insert that into my base. Height is 4. So sometimes the problem gives you height in reference to something else. So they would say maybe, oh, height is twice the length of base, then I got to do 2 times this. Or it's half the length of the base, then I got to do 1/2 times this. But here it's telling us the exact numeric value. So we're we can replace height with a direct numeric value. Height is just 4. All right, so our area, base times height, multiply these two together. I'm just going to push the coefficient in front. Okay, so now we're ready to build our volume formula, right? Our volume formula, we're doing right minus left, horizontal base length, so we'll choose this one here, horizontal base. No pi, right? No rotation here. Our y1, y2, same bounds, right? We're stacking these rectangles from lowest to highest y value. So we're going to go from 0 to 1.609, same as before. We'll insert our area expression into this space. Enter all this into the calculator. And we should get 16.189. No pi, no rotation, no circles involved. So we just end here and say units cubed. All right, any questions? Okay, so immediately after class ends, I'm going to go over to the help session channel, open that up. We'll do some more practice problems. Tomorrow morning help session, it'll be recorded. And I'll try to get that morning review ready this afternoon tonight. So if any of you want to get additional practice, you can have that available. And then test tomorrow, 7 questions. Okay, very similar to what we've been doing. All right, thanks everyone. Study for your test. If I don't see you at the help session, I'll see you guys in class.
Thank you. Have a
Take care,
good
guys.
afternoon.
Thank you. Have a good
Have a good
afternoon.
afternoon.
Thank you.
Thanks, guys. Bye.